Welcome to Wickerson Studios again. I'm extremely interested about this video, and it's a video I wish I was shown long before I'd spent, so much time dancing around plugins and looking at things. I've learned Grasshopper pretty much on my own. I come out of an art school traditionally. There's not a lot of people within that school that could give me any assistance on this. I was directed that way because students were taking an interest in CAD. And then a couple of them, Mal Murrow was the name of someone that said, hey, check out this Grasshopper stuff. Anyhow, this is the tutorial I wish I'd seen because I have a math background and I just left math because I couldn't see everything. I couldn't visualize it. I had no vision towards it. But I think I have it now. So in looking at this script, I am very excited to go into the maths and get into the trig. Trigonometry has always been one of my most enjoyable things to play around with in early algebra, but definitely going into all the triangle theorems I remember in high school, isosceles triangle theorem. Enough said. What I'm going to do is jump in here from cosine through to secant and actually focus in on just, actually this is cosine and I don't think I'm going to use that one. I think I'm going to focus in on just sine, which is down here. So I should probably swap those over and put that one here, put this one down here for now because I'm not going to be looking at it. I'm going to be looking at this one. So sine is basically being applied. And what I want to show you here, and it may look a little dry to start, but there's a vessel here. It's pretty simply made. I start with a range, I build a series of points that's basically informed, if I follow this one, by a sine curve. That you have a range and you pull the range into a value. I do a little multiplication even though I keep it at 1, so this is actually not even needed at all, this multiplier right now. I may use it later, but I'm going to plug that directly into the y while leaving the range in the z and doing an added 11 to the x, which gives me this series of points of a sine curve that is fully functional. I can change the amount of interpolated points on it, and without amplifying anything or changing anything. I mean, definitely you could go in here and amplify it. Just think of it as a sine curve in a different direction with a certain domain that's within it, that's on it. So I can make that longer, smaller, I can elongate that vessel or form, or whatever you think of. That's enough said. A lot of people who did math or trigonometry got close to that. I have a 3-year-old who's screaming like crazy, so bear with me because my life is full of children and I don't have any excuses for it. Basically, I interpolate that curve, and there it is. So you go from points to interpolated curve, and I throw it into a very quick revolution, setting up a vector, just setting up a line that will, I mean, if I visualize the line, it's not too hard. You should be used to this by now, but there's a little visualized line down here saying revolve me around that line. And there's your surface, and that is basically how maybe someone like me with a math background will come in and make a vessel using a bit of trigonometry. Another person might say, hey, I know the evaluate tool. I want to go in, write an expression, sine x, plug in x, come out with a value, and take that same value and put it into that multiplier, and end up with exactly the same thing. I just ended up with exactly the same thing. So if I wanted to change this and go in and say, okay, I want 2 sine, because that's how I think, there, I've changed it, and I've busted the script, because it's like, no, you wrote a script that didn't say 2 times. And there you go. I wrote 2 times and I got it. So somebody who knows how to script and write and get this correct, it doesn't correct your mistakes if you're doing this one. So that's why I like this one, because if you go into the expression node, it'll say, if you type in 2 sine, it'll say, oh, cannot be evaluated, until you type in that and it says no errors detected. Type that one in and take your function coming out of the expression node and plug it into there, and you have the same one. And if I go back in and I start playing with bringing that back down to where it was, there you go. You've got it back to the original form. So the same thing coming out of sine here is the exact same thing coming out of sine here. Now there's the mathy in me. That's something you might be interested in. There might be, and I'm kind of a visual artist, programmer, engineer, architect, thingy, whatever. I do whatever I want as a jack of all trades. Some people aren't like that. Others would go in and write in C programming, sine x, have its inputs and outputs in C because they know that language. Another person would do it in Python, which I'd be capable of doing, but I don't find the need for the simple script to go there. And VB script is another one somebody might play with. Now, for the visual artists that I'm teaching, I definitely think they're interested in this, using the graph mapper. Pull out the range, put it through the sine. You don't have to put it through that sine. You put it through a sine curve physically. And in doing so, what I've done is I've amplified. You see a little slight change that happened there. When I hit on this, I actually changed the domain of X to 0 through 11 to somewhat match the domain that's coming out of here. And it was 9, but now I'll have to go back to 11. I think that has an effect, or the steps have an effect on it, 10. But what I can do is go in and I can move this thing around. I can make different shapes. If I make different shapes, I see that change. So if I pull this in and want to flatten that and start to change that shape, have I actually done that through the amplification? Did I leave my data? It should be fine. I should be able to gain some control off of this, even though I think I probably should have amplified more that iteration. We'll see what happens when I start playing this. There, I get my wiggly jigglies, and I start to shape this because I have not an analytical mind or mathematical mind to use math and logic. I actually have some, I believe some intuition. I like to work with my hands, but all this does is substitute. And my picture's down here. You're going to say, well, where's your lovely face, Michael? I say, well, I have this camera going for a reason. But usually, I'd be working with, we'll go in here, and this is a way of taking your numbers and logic and going into using this mouse as a pen and the keyboard or the screen as kind of your canvas. And that's something that I think a lot of people would do. And what you can end up doing with this is just going in and setting all the graphs you want, changing them up. I know it's going to blow up if I hit parabola. No, it didn't blow up too bad because I have it set pretty well. But parabolas, you just change around the graph, go in, you can add multiple graphs to it. So you can have a parabola informed by, this is why I wish somebody, I'd seen these demos all in one spot. Pull that one in over to here, and now I've got not only two parabolas I can play with and mess with. It's not really going to have a major effect there, but if I grab another graph type, I'm pretty sure that might affect it, but it didn't. It could be that my domain in this one is not even close to the other one. No, I cut and paste it. We'll try one more, and if not, I'd have to play around with it to get my head around it, the Bezier curve, and see what I could do. As long as I have that geometry informed by it, I think I'm okay. Maybe this is overpowering it. The sine is still here. I probably killed the sine. I'm dealing with, let me just check that I've got all my data in there. I did not have this data running through. I've got my sine curve that's still influencing it here. What's going to happen if I take that one and plug it on up into there? I'm going to kill it for sure. But I've got to play with my numbers, and I've confused myself to death, so it's probably like time to just reset that, play with my sine curves the way I was, plug them into the points. Remember, you're just really changing this sine curve that's over here, or whatever curve you're bringing in. Now, that said, I wanted to go here. I wanted to actually leave this and say, look at this, a nice FireFly audio that's capturing data. And this data here, if I talk real quiet, and my kids are not yelling, which they are, and I'm always looking at data to see what's coming out. This is coming out of the visual. This is coming out of the audio. And if I take that data and I bring that up here to this curve, and maybe if I plug it into here, that is not where I want to go. Hang on, I might want to go into my amplification, but I'm taking data from my audio, putting it in, and there we go. If things get quiet, it's way too amplified. But I have a geometric, and I'm just snapping my fingers. So as you can see, I can amplify it, with bugs crawling across my screen. So that's for the person that's much more intuitive, sees music as number as sound, colors as art. I wish I had this play. Now let me take the last bit of data, and I'm always checking my data, and I amplified it. I'm going to grab this one, and I'm going to grab it. I'll probably plug back in my sine, which would be probably the best bet. Into the amplification here. End up with this one. And then let's try and amplify it somehow, maybe with this visual. And of course, I'm having trouble with my script, getting that little visual to come up here and plug into here. And at this point, let's, yeah, there we go. Let's see if I've amplified it enough. No, it's reading my colors on my map. Like, how can I affect that by my visual, not my sound? It might still be influenced by the sound, but I've killed it. But I've also brought, I may have to bring it into amplifying along. Well, I left the 12 amplifier in there. Let me go back and see if I can't bring it in another way. And I'm pretty sure this is going to blow it out of the water as well. No, that's a good one. Okay, so I'll end on that one. I got lucky. So me as a person, am influencing this pot, like, because I'm so beautiful, and you can look at me in my shirt. I mean, it's blue and white. I'm not sure if I put green in front of it, what it wants to do in response to that. Or maybe it's picking out, it's a bitmap that's riding it, so if I go to the ceiling, it might change it. So what a way to control geometry because of visuals. So I had a fellow recently who said, hey, you've got this folder, I could put this in the foldogram, this could be floating in the room, I could react to it in AR. Once things go digital, and number is being recorded and bitmaps are there, anything is possible. That's why you're seeing all this augmented reality and VR. We've chosen to go into that way of seeing, and that whole world is opening up to us. So that's a passionate big talk. It's chaotic as anything, but I wish somebody had laid out, you don't have to think this way. You don't have to use this node. You don't have to use that expression. You don't, I mean, you basically could go right into that range and into that value list here, and you could click your little expression node, I believe over here in X, and if I could get it to come up on my screen, I could do an expression and multiply that by sine X to get this happening. So you start simple, and then change it up. Start using your cosecant, your secant, your tangent, all the other things that are related to triangles. And that's why this section for me, I'm so passionate about as I move through these and think about these right it's called trigonometry. Well, trigonometry, definitely, but when you're dealing with circles, orthocentric, circumcenter, incenter, centroid, all these things I'm going to come into play. And whether you're a radians or degree person, whether you're an engineer, architect, or artist, designer, a musician, all the dancer, all this should be coming into Grasshopper. And this should be a means of a whole form of study of digital sculpture in the 21st century. Thanks so much for listening.